Today we are going to discuss the important questions on hydrology and irrigation. Okay.
Yes, sir.
I hope I am audible to you. My voice is clear to you.
Yes, sir.
Okay. First, please tell me the answer for this. An isoheight is a line joining points of. What is an isoheight?
Rainfall depth.
Yeah.
Equal rainfall depth.
Iso means same. Height means rainfall depth. So here we have the option as option C.
Yes, sir.
Next. Let's do this. A catchment is idealized as a 25 kilometer by 25 kilometer square. It has 5 rain gauges, one at each corner. So here you have a rain gauge. Here you have another rain gauge, Z2, Z3, Z4 and Z5. You have 5 rain gauges. And the total catchment area is how much?
25 by 25 kilometers.
25 kilometer on one side and 25 kilometer on the other side. That means it's a square. The total area is 25 into 25, 625 kilometer square.
Yes, sir.
It has 5 rain gauges, one at each corner and one at the center. During a month, the precipitation at these gauges is measured as precipitation at gauge 1 300 mm, Z2 285, Z3 272, Z4 290 and Z5 is 288 mm. The average precipitation over the catchment during this month by using season polygon method is. How do we do this? Tell me. Any idea how are we going to do this? So in Thyssen polygon method means we need to shape out this area. That means using the area we will be calculating. Using the area, we will be calculating the average precipitation. That means how much area is contributing to Z1, how much area is contributing to Z2, how much is to Z3, how much is to Z4. For suppose, if you have a catchment like this and if you have 4 rain gauges at the corners and if you don't have anything in the center, then what happens is the area will become like this. That is, the total area will be shared equally by the 4 rain gauges.
Yes, sir.
But now in this case, what we need to do is first draw the perpendicular bisectors. For this Z1, Z2, the bisector looks like this. Yes or no?
Yes, sir.
Z1, Z4, the bisector looks like this. Z2, Z3, it looks like this. Z4, Z3, Z4, it looks like this. Yes or no?
Yes, sir.
But we also have Z5. Therefore, the area covered by this portion will be in the shape of a square or diamond inside it. Okay.
Sir.
Now, if this is, let's assume this to be a square of side a kilometer. If this is a, what about this portion? Tell me.
A by 2.
A by 2. And what about this one?
A
A
by
by
2.
2. What about z1 to the half? A by 2.
By 2.
A by 2. A by 2.
By 2.
A by 2. A by 2 and A by 2. Okay. Now
Yes, sir.
this is A by 2 and this is A by 2. Can you tell me the area of this triangle?
A square by 8.
Half BH. Very good. A square upon 8.
Yes, sir.
Very good. A square upon 8. And this will be also equal to A square upon 8.
Yes, sir.
And this will also be equal to A square by 8. A square by 8. That is all together, how much it will become? Tell me.
4A square by 8. A square by 4.
A square by 2.
2A square by 2, sir.
So the central part will be A square by 2.
Yes, sir.
Now let's take the weighted average. Average precipitation P average is equal to A1 Z1 plus A2 Z2 plus A3 Z3 plus A4 Z4 plus A5 Z5 upon, I want P, so we need to divide with area.
3.
A1 plus A2 plus A3 plus A4 plus A5. Am I right?
Yes, sir.
Now how much is A1? A1 means the area corresponding to Z1.
A square by 8.
A square by 8. Very good. A2 is?
A square by 8.
A3 is A square by 8. A4 is A square by 8. Yes or no?
Yes, sir.
So can I take A square by 8 as common?
Yes, sir. From 4 to.
So this becomes Z1 is 300, Z2 is 285, Z3 is 272, plus Z4 is 290, plus A5 is how much?
A5 is A by 2. A
A
square by
square
2.
by 2
Yes, sir.
into 290, sorry 288.
288.
Whole divided by total area is how much?
Sir, total area is 25 into 25.
Yeah, but we are taking in terms of A. Then the total area becomes how much?
Yes, sir. A square.
Can I cancel out A square, A square, A square?
Yes, sir.
So tell me the value now. Add all these 4 and divide with 8 and plus 288 by 2. That gives you the answer.
Sir, 287.375.
Very good. It's 287.375 mm.
Yes, sir.
So do this question. You have the rainfall depth at the particular rain gauge. You have the corresponding area also.
Sir.
Okay.
Yes, sir.
Take a couple of minutes and this is from GATE 2018. Do this question then.
Sir. Sir, 479.09.
So average precipitation, right? Isn't mean value is nothing but average precipitation.
Sir.
Four 70 into 95 plus
465 into 100 plus 435 into 98 plus 525 into 80 plus 480 plus 8 into 40 85 plus 510 into 92 over 95 plus 100 plus 98 plus 80
into
plus
85 plus 510 into 92 upon what's the see
total
we
area.
have the total area into 10 power 4.
Yes,
I'm
sir.
taking 10 power 4 as common.
Sir.
Divide by what is the addition of all these things now? 195, 293, 373, 378, 458, 460, 550.
Sir.
Is it 550?
So just 90. Yes, sir. 550. Yes, sir.
So when I'm multiplying all these things, what is the answer we got?
Sir.
Don't include 10 power 4. Let's leave it.
What, sir?
Don't include 10 to the power of 4.
Yes, sir.
Because here also we have 10 power 4. Here also we have 10 power 4. We can cancel it down.
Yes, sir. So 479.09.
479 point.
09.
Very good. Units.
Sir.
Mm.
Sir.
Because this is in mm and this is in meter square. This is also in meter square. Meter square and meter square gets cancelled. We will be getting in only.
Yes, sir.
Moving forward. Do this. A 1 hour rainfall of 10 centimeter magnitude. We have a 1 hour rainfall. That is rainfall is occurring for 1 hour. What is the magnitude? That is the depth of rainfall is
10 centimeter.
depth is 10 centimeter. And a station has a return period of 50 years. Okay, has a return period of 50 years. The probability that a 1 hour rainfall of magnitude 10 centimeter or more will occur in each of 2 successive years is. Get an idea how to do this? What is given?
Sir, return period. Not in full of 10 centimeter.
See, when you have the return period, first we calculate the probability of occurrence. So that is P is equal to 1 by return period. That is once in every 50 years it's occurring means in 1 year what is the probability of occurrence? In 50 years the probability of occurrence is 1.
Sir.
Yes or no?
Yes, sir.
In 1 year what is the probability of occurrence? 1 by 50.
Yes, sir.
How much is 1 by 50? It's 0.02.
Yes, sir.
Now let's calculate the probability of occurrence r times in n successive years.
Sure.
Okay. The probability that 1 hour rainfall of magnitude 10 centimeter or more will occur in each of the 2 successive years. That means when you are taking 2 years, in each year it is occurring means how many times it is occurring? Are you understanding my point, my dear?
Sir.
First year it is occurring once, second year it is occurring once. That is how many times?
Yes, sir.
R is 2.
Sir.
How many years we have?
2.
2. N is 2. Yes or no?
Yes, sir.
That's given by the formula NCR P power R Q power N minus R.
Yes, sir.
NCR is nothing but N factorial upon N minus R factorial into R factorial into P power R Q power N minus R. Where R is 2, N is 2. Substitute them. 2 factorial. N factorial is 2 factorial. N minus R 2 minus 2 0 factorial. And R factorial 2 factorial. P is 0.02. Power R is how much? 2.
R is 2.
Q is how much then? See, always we have P plus Q is equal to 1.
1.
P is probability of occurrence, Q is probability of non-occurrence.
0.98.
0.98. 0.98 per N minus 8 is R is 2 minus 2 is 0.
0.
Tell me the answer. 2 factorial get cancelled. 0 factorial is 1. Anything per 0 goes to 1. And 0.02 whole per square 2.
Yes, sir. So 0.04. 0.04.
0.04. Good. Wait, 0.02 whole square.
Yes, sir.
Do this properly.
Four into 10 power minus 4.
That means 0.0004, right?
Yes, sir.
Okay. Next, a culvert is designed for a flood frequency of 100 years. That is, a flood is occurring once in 100 years.
Yes,
Useful life of culvert design life is how much? 20 years. Risk involved in the design of culvert is dash percentage. Risk means
probability.
Probability of occurring.
Yes, sir.
Occurrence of the flood here. Probability of occurrence of the flood at least once. Probability of occurrence of the flood at least once. Can I say probability of occurrence at least once means 1 minus probability of non-occurrence?
Yes, sir.
P of R equal to 0.
Yes, sir.
1 minus P of R equal to 0 means NC naught.
0.
P power R.
0.
Q power N minus R.
Yes, sir.
NCR P power 1 minus
20.
20 number of years design life 20. C naught.
P power 0.
Anything C naught is 1, right?
Yes, sir.
Into P is how much? 1 by T.
Yes, sir. 1 by 100.
1 by 100, that is 0.01.
Yes, sir.
0.01 to the power 0. And next 0.99 to the power
18.
20 minus R is 0.
Okay, sir. 20.
20. Tell me how much is 1 minus 0.99 power 20? Because anything to the power 0 goes to 1, 20, NT naught goes to 1.
Yes, sir. Sir, 0.182.
That is it the complete value you are telling me?
Sir, yes.
0.182. What is the next digit?
1209.
182.
09.
0.18209.
Yes, sir.
That is 18.21 percentage,
Yes, sir.
or simply 18.2 percentage.
Yes, sir.
I'll just let me check the answer for you. Yeah, it's 18.209%. Shall we move forward?
Yes, sir.
Risk questions are very, very, very important.
Sir.
Do this. See, this occurred in 18. Similar question you got in 19 also. I want you to do this. Take a couple of minutes and do this.
I can't do it, sir. Sir, I can't do it, sir.
Why? It's very simple, my dear. What happened? Tell me. Where you have the doubt?
Sir, the return period for sir, it is asked to calculate n or what, sir?
Return period is asked, na?
Yes, sir.
T.
T. Okay, sir.
T is how much? The probability that annual maximum flood discharge, listen, annual maximum flood discharge will exceed 25,000 meter cube at least once in next 5 years is 0.25.
Sir.
That is, can I say at least once means can I say 1 minus probability of non-occurrence
Yes, sir.
is how much, ma?
0.25.
0.25. Okay. Now, 1 minus probability of non-occurrence means P of R comma N is NCR, P power R, Q power N minus R
Yes, sir.
is equal to how much?
0.25.
0.25. Now, what is N?
Sir, we are getting n from n equals to 1 from here.
No. N is equal next 5 years, right? At least once in how many years?
Next 5 years. NC5, 5CR, 5C1.
5C not. Okay.
Yes, sir.
5C not. Next. P power R.
P power 0.
P is how much? We don't know. Because P is from 1 by T.
Sir.
P power 0. Good. P power 0 goes to 1.
Sir.
Phi C naught goes to 1. Yes or no?
Yes, sir.
Q is 1 minus P.
Yes, sir.
Power n minus R.
Yes,
Phi
sir.
minus 0
Yes, sir.
equal to 0.25. 1 minus P, how can I write it? 1 by T
Yes, sir. Yes,
is
sir.
equal to 0.25.
Yes, sir.
Is equal to 0.25 then.
Yes, sir.
Now tell me, I am bringing this 0.25 to this side. 1 minus 0.25 is equal to 1 minus 1 by T whole power 5. Yes or no?
Yes, sir.
Now 1 minus 0.25 is how much?
0.75.
0.75 equal to 1 minus 1 by T whole power 5.
Yes, sir.
Now 1 minus 1 by T equal to 0.75 to the power 1 by 5.
Yes, sir.
How much is the value? How much is the value, ma? 0.75 to the power 1 by 5. How much is it?
Sir, 20.
Pardon?
T equals to 20.
Okay. First, can you please tell me this answer?
Sir, 0.944. 944.
0.944. Okay. Now 1 minus 0.944 is equal to 1 by T.
Yes, sir.
0.056 is equal to 1 by T.
Yes,
T
sir.
equal to how much?
Sir, 17.85.
17 point.
85.
Yes. I'll tell you the answer. How much is it in the key then?
Sir.
Yes, we got 17.85. The answer is from 17.5, 17.5 to 18.5. Okay.
Yes, sir.
Anything in this range will give you right full marks.
Sir.
2 marks. Okay.
Okay, sir.
Moving forward. Let's do this. The total rainfall in a catchment of area 1000 kilometer square during a 6-hour storm is how much?
So 19 centimeter.
19 centimeter. The total rainfall we have it is 19 centimeter. Then the surface runoff due to the storm computed from a triangular direct runoff hydrograph is how much is it? 1 into 10 power 8 meter cube. Runoff volume is given to you.
Yes, sir.
Okay.
Yes, sir.
Phi index for the storm is, what is the formula for phi index?
Sir, phi index equals to.
PE minus R upon TE.
Yes, sir.
Yes or no?
Yes, sir.
Okay. What is R?
R is a runoff.
Very good. Very good. So runoff we have the runoff volume.
Yes, sir.
We have the runoff volume. How much is the
Runoff
runoff volume?
10 raw power
10
8
power 8 meter
Yes,
cube.
sir.
What is the area?
Divided by area
Runoff is
1000,
occurring in the catchment itself. What is the area?
10 power 3
1000 kilometer square, right? But I want in
meter square.
1
Yes, sir.
kilometer is 1000 meter.
Yes, sir.
Therefore, it's 10 power 6 meter square.
Yes, sir. 10
Yes or
power.
no?
Yes, sir. 10 power 9.
So, runoff depth is equal to runoff volume upon area
8.
of the catchment.
Yes, sir.
That is 10 power 8 upon 10 power 9. How much is it? 1 by 10.
Yes, sir.
0.1 meter.
Yes, sir.
That is 10 centimeter.
Yes, sir.
Now, we have a 6-hour storm we have. Let's substitute this in phi index then. Phi index is equal to PE. Effective rainfall is how much? Total rainfall is how much?
19 centimeter.
19 minus R is how much? Runoff is 10.
10 centimeter.
Upon effective time is how much? 6 hours.
6 hour.
So it's 9 by 6. How much is it?
1.5 centimeter per hour.
Is it?
Yes, sir.
Let me tell you the answer. Yeah, it's 1.5 centimeter per hour.
Sir.
Moving forward.
Yes, sir.
Next class, we will be doing 24 and 23 questions.
Okay, sir.
That is in tomorrow's session.
Yes, sir.
Let's do this.
Sir.
Yeah. The infiltration rate F in a basin under ponding condition is given by F is equal to 30 plus 10 e power minus 2t, where F is infiltration rate in mm per hour, t is the time in hours. The total depth of infiltration during the last 20 minutes of a storm of 30-minute duration is how much? Now, this is nothing but a form of Horton's infiltration equation. What it is, ma?
Horton's infiltration.
Equation. Horton's infiltration equation. Horton. Okay. That's given by the formula actually. Ft equal to Fc plus F naught minus Fc e power minus Kt. Understanding?
Yes, sir.
So, how much is Fc? When you compare this with the equation, how much is Fc then?
C is equals to 30.
Fc is 30. Very good. How much is F naught then?
Sir, F naught is FC. Sir, minus FC. Sir, 20.
Once again. F naught minus Fc is 10.
40, sir.
40. Very good. F naught is 40. K is how much?
Sir, K
2.
is 2. Yes, sir.
Sometimes they will be asking such type of questions also. How much is K? how much is F naught from this equation, like that.
Sir.
Okay.
Okay, sir.
Now what we do is we will simply integrate.
Sir.
Okay.
Yes, sir.
That is, in total infiltration I am writing in capital F. Total infiltration capacity is denoted with small f. Total infiltration is denoted with what?
Capital F.
Okay, but what is asked? Total depth of infiltration during what time?
Last 20 minutes.
Last 20 minutes of a 30-minute storm.
Yes, sir.
That is, we require it from 10 minutes to 30 minutes. Am I right?
Yes, sir.
Last 20 minutes of a 30-minute storm means it's from 10 minutes to 30 minutes.
Right.
30 minutes, but here everything is in mm per hour. So let's convert the minutes to hours.
Yes, sir.
What is 10 by 60? How much is it? And how much is 30 by 60?
0.17.
0.167.
Yes, sir.
30 by 60 is 0.5.
Sir.
So let's integrate with the limits. Lower limit is 0.167. Upper limit is 0.5. Off with the equation 30 plus 10 e power minus 2t dt.
Yes, sir.
Now tell me the integration 30 integral 1 dt is t.
30t plus minus 2t minus 2t 10
plus I'm writing 10 e power minus 2t by minus 2. Yes or no?
Yes, sir.
So plus will become minus 10 by 2 is 5. 5 e power minus 2t.
Yes, sir.
With the limits
0.167 to 0.5.
0.167 to 0.5. Substitute and tell me the answer. Take 2 minutes or a minute. Tell me the answer. Hmm.
Zero point two two. 0.225.
0.225.
225.
Right? No. See, let's do this first. T, when I'm writing this in T, how much is it? 0.5 minus 0.167.
Yes, sir.
Minus 5 e power minus 2 into 0.5 minus e power minus 2 into 0.167.
Yes, sir.
How much is this one? First tell me this. 30 into 0.5 minus 0.167. That's 0.33.
Yes, sir.
Yes or no?
Yes, sir.
How much is it then? 30 into 0.33 is how much, ma?
9.9.
That's 10.
Yes, sir.
Minus 5 into how much is e power minus 1?
E power minus 1. Sir, 0.367.
0.367. Okay. Minus e power minus 0.33. How much is it? Tell me e power minus 0.33.
0.718.
Now, see, I'm telling you, be careful while calculations. Now tell me this answer, 0.367 minus 0.718.
Sir, minus 0.351.
Minus,
Minus 0.351.
so tell me how much is 5 into 0.351?
Sir, 1.755.
So 10 plus 1.75. How much is it then?
So say 11.75.
Mm.
Yes, sir.
But how much is the answer you got earlier then?
Yes, sir.
Is it?
That was very higher value.
Okay. Shall we move forward?
Yes, sir.
Yes. Do this question. Look, at a station, storm 1 of 5-hour duration with intensity of 2 centimeter per hour resulted in a runoff of how much?
4 centimeter.
4 centimeter. So, Phi index is same, he is telling. Storm 2 resulted in a runoff of how much? Phi index is asked. Okay. So
Yes.
first let us see. Phi index is same.
Yes, sir.
Phi index for storm 1 is equal to phi index for
To
storm
storm.
2. It's a 2-mark question actually.
Sir.
So for storm 1, phi index is given by the formula PE minus R upon TE. Yes or no?
Yes, sir.
That is rainfall minus runoff divided by time. Phi index.
Yes, sir.
PE minus R upon TE upon 2 for 2 second storm.
Yes, sir.
Now, how much is fire duration with intensity 2 centimeter per hour? How much is the rainfall in this case?
5 into 10 centimeter.
10. 5 into 2 centimeter per hour is 10. How much is the runoff in first case?
4 centimeter.
How much is the time in the first case?
4. 5 hour.
5 hour. That is equal to. That is your phi index. How much is phi index then? Of 1.
1.2.
6 by 5, that's 1.2 centimeter per hour. Okay. Next, talking about storm 2. Storm 2 of 8-hour duration resulted in a runoff of 8.4 centimeter. That is PE minus R of TE for the second storm. Phi index is same.
Yes, sir. 1.2 centimeter.
So PE we don't know. PE 8-hour storm. We don't know PE.
Yes, sir.
This is not phi. Phi index is okay. One part is done.
Yes,
How
sir.
much is phi index?
1.2. 1.2.
Phi index is done. 1.2.
Yes, sir.
And next, intensity of storm 2 I require.
Yes, sir.
Intensity of storm 2 means I want PE. From that I'll be getting the intensity minus runoff is how much?
8.4 centimeter.
8.4 upon T is how much?
T is 8 hour.
Is equal to 1.2.
Yes, sir.
P is equal to 1.2 into 8 plus 8.4. Yes or no?
Sir, 18.
18 centimeter.
Centimeter. Yes, sir.
But I want the intensity, not the rainfall.
Yes, sir.
Intensity is equal to rainfall by time.
Yes, sir.
18 by time is how much?
Sir, 8 hours.
How much is it then?
Sir, 2.25
Centimeter per
hour.
hour. Good.
Yes.
Answer is answer D.
Yes, sir.
Option D.
Yes, sir.
Yes, let's do this. This is a question on hydrographs.
Yes, sir.
It's directly we can do it with the help of a table. What is given first now? 4R unit hydrograph is given. What would be the maximum ordinate of S curve derived from this hydrograph? Okay. How to do S curve? First we take T in R's. Next we take unit hydrograph ordinates. in meter cube per second. Understanding?
Yes, sir.
How much is the T in hours? Tell me. 0,
0, 2, 4,
4,
6,
6,
8,
8,
10.
10, 12, 14. How to draw S curve? I will show you here.
Yes, sir.
18, 20, 22, 24. Yes or no?
Yes, sir.
Next, we will be having the UHZ ordinates, unit hydrograph ordinates. How much are they?
0, 0.6,
0, 0.6,
3.1,
3.1,
10,
10, 13, 9,
10,
5, 2,
0,
0.7,
0,
0.3,
0.
0.2, 0.1 and 0.
Yes,
That is
sir.
starts with 0, ends with 0.
Yes, sir.
Starting with 0, ending with 0.
Yes, sir.
Now, let's do one thing. 4 are shifted. That is, we will be shifting this with how much is the unit hydrograph ordinate? 4 hour, right?
Yes, sir.
So this we will be shifting by parts.
Yes, sir.
So first what I require? 4 hour shift UHZ.
Yes, sir.
4 hour shift UHZ means directly start from 4 now.
Yes, sir.
The same ordinates, right from 0 what you have, start from 4. Shift
Yes,
them
sir.
down. Now where I will be getting 0 opposite to?
4.
Yes, opposite to 4, 0. Next.
Sir, 0.6,
Next.
3.1,
10,
30,
13,
9,
9, 5,
2,
2,
0.7,
0.7,
0.3,
0.3, 0.2, 0.1, 0. Yes or
0.
no?
Yes, sir.
What is the next shift? Tell me.
Sir, 8.
Very good, very good. 8 hour shift UHG. This like you need to continue like this actually.
Yes, sir.
Now where this ordinate starts now?
8 from 8.
Very good. 0, 0.6,
3.1,
3.1,
10, 13,
10, 13,
9, 5, 2,
9, 5, 2,
0.7, 0.3, 0.2.
0.7, 0.3, like that we will stop now. Next, how much is the next one?
Sir, 8. 12, sir.
12 hour shift.
Yes, sir.
4 after 8 is 12, right?
Yes, sir.
From where we start now?
12.
Opposite to 12. 0, 0.6, 3.1, 10, 13, 9, 5, 2. We will stop.
Yes, sir.
Next shift,
16.
16 hour shift. How much is it now? Where we will start then? 0,
10,
0.6, 3.1,
10, 13.
10, 13, 9. Next shift,
Sir, 20.
20. From where we will be starting now? 0,
0,
0.6,
3.1.
3.1. Let's stop it. Now, we have done all the shiftings. S-curve coordinates I want. Summation. What is the summation at 2? 0. 0.
Yes, sir.
What is the summation at 2 hours?
Sir,
Sum up all these things.
6.6.
0.6. Next, what is the summation here?
3.1.
3.1. Next, what is the summation?
10.6.
Next, what is the summation?
Sir, 16.1.
What is the next summation?
19.6.
19.6. What is the next summation?
21.1.
5, 3, 18 plus 3.1, 21.1. What is the next summation? 2, 9, 11,
21.6.
21.6. What is the next summation, my dear? 16.7, 5.7, 18.7, 21.8.
Sir.
Yes or no?
Yes, sir.
What is the next summation? 0.3 plus 2. 0.5
3.
plus 9. 9.5 plus 10, 19.5 plus 6. I'm going backward. 10 plus 0.6, 10.6, 19.6, 21.6, 21.9. Let's look at it once again. Is it
2.5, 11.5, 21.5,
0.3 plus 2 is 2.3.
21.21,
Wait. 0.3 plus 2 is how much?
2.3,
Plus 9
11.3,
plus 10
21.3,
plus 0.6,
27.3,
21.9.
21.9, sorry.
Next to the next summation.
0.9, 5.9,
Yes.
0.9, 22.9,
5.9 plus 13
sir, 18.9,
plus 3.1.
sir, 21.1,
Pardon?
sir, 19, 19, 11, 11.3, 7.7.
It's 22.
Yes, sir, 22.
Next to this zero point 0.1 plus 0.3, zero point 0.4 plus 2, 2.4 plus 9, 11.4 plus 10, 21.4 plus 0.6, 22.
Yes, sir.
Next, let's do here. 0 plus 0.2, 0.2 plus 0.7, 0.9, 5.9, 18.9, 19 and 3, it's 22.
Yes, sir.
Okay. S
Yes,
curve starts like this, goes to a maximum, remains constant.
yes, sir.
So where is it becoming constant? At 20 hours. So
Yes,
what
sir.
is the maximum ordinate of S curve now?
Sir, 22.
22. That's it.
Yes, sir.
Try this. Take a couple of minutes, give a try. Okay, let's do this. Have you tried? Have you tried?
Yes, sir.
Okay. What is the answer? Don't be worried. We'll do this. Just for a trial, because while you are trying, you will be getting some doubts.
Yes, sir.
That is the reason I'm asking you to try. No, no problem. Tell me. It's very simple. I'll tell you. What is given now? The ordinates of a
2 hour unit hydrograph.
2-hour unit hydrograph. What do you mean by unit hydrograph? Runoff is 1 centimeter.
Yes, sir.
What do you mean by unit hydrograph?
Runoff is 1 centimeter.
Okay. The unit hydrograph ordinates we have. T we have, U we have. What is the time we have? 0,
1,
1,
2, 3,
2, 3, 4,
5, 6.
5, 6, 7, 8, 9, 10, 11, and 12.
Yes.
Okay. What do we have next? We have 2-hour unit hydrograph ordinates. Yes or no?
Yes, sir.
2-hour UHZ ordinates we have. What are they?
0,
0.
2.
Always unit hydrograph starts with 0, ends with 0. Okay.
Yes, sir.
18, 32, 45, 30, 19, 12, 7, 3, 1, 0. Okay.
Yes, sir.
What are we asked, Madan? 6-hour storm is occurring, my dear. How much storm is occurring?
6 hour storm.
So how many shifts we require?
3.
3. First DRH R1 equal to, first we want first direct run of hydrograph, or else we will do one thing. First, from the unit hydrograph, we will calculate 2-hour DRH ordinates. What are we calculating? 2-hour direct run of hydrograph ordinates.
Yes, sir.
Direct run of hydrograph also starts from 0, ends with 0. Okay.
Yes,
This is 0 into, how we do it is, I'll tell you how we do it is, with what we need to multiply. Tell me. Let's see the equation.
yes.
A 6-hour storm occurs over the catchment such that effective rainfall intensity is 1 centimeter per hour for the first 2 hours.
Yes, sir.
Runoff is how much? 1 centimeter per hour for first 2 hours. Runoff is 2.
Yes, sir.
Yes or no? First
Yes,
hour 1.
Yes, sir.
Next hour 1. Runoff is 2.
Yes, sir.
Okay. Runoff is 0 for the next 2 hours.
Yes, sir.
And 0.5 centimeter per hour for the last 2 hours. Here the runoff is how much?
1.
1. Very good. Just a minute. So runoff is 2. Runoff is 2 plus how much is the runoff?
2 plus 1, 3.
3. Okay. And first DRH where runoff is, listen. First DRH I am talking. In the first 2-hour direct runoff hydrograph, that is in the first 2 hours, how much is the runoff, ma?
2.
Runoff is 2. So we need to multiply. Direct runoff hydrograph means we need to multiply it with runoff.
Yes, sir.
DRH is nothing but UHZ ordinate into runoff. Are you
Yes.
understanding?
Yes, sir.
I'll show you. Look at this, ma. This is runoff. time. Okay.
Yes, sir.
This is your unit hydrograph ordinates. Okay.
Yes, sir.
This will be your DRH ordinates.
Yes, sir.
Always direct runoff ordinates is nothing but unit hydrograph ordinates into runoff.
Yes, sir.
Now here comes your FHZ, flood hydrograph ordinates.
Yes, sir.
So flood hydrograph ordinates, FHZ ordinates is equal to direct runoff ordinates plus base flow. What it is? Direct runoff hydrograph ordinates plus
Base
base
flow.
flow. Understood?
Yes, sir.
Now going backward. Now DRH I want. What I need to do? Unit hydrograph ordinates into runoff. Yes or no?
Yes, sir.
So this is 0. 0 into anything is 0. Next, how much is this value? Runoff is 2.
Yes, sir. 2 into 2, 4.
Next.
16.
Next.
36.
Next.
64.
Next.
90, and
60. 38. 24. 14. 6. 2. 0. Yes or no?
Yes, sir.
Next, I want one more 2R DRH ordinates with runoff is how much?
2.
0.
Sir, 0, sorry.
Because next 2 hours, what is the runoff?
0, sir.
0. So 0 into 0 is 0.
0.
Now where we need to start it, ma?
Sir, 2. So 4.
We need to start it from 2. See, already it is 2 hours. So
yes,
we are starting after 2 hours.
Yes, sir. 4 hours.
Because listen. It is first 2 hours.
Yes, sir. Okay,
Next
sir.
2 hours means it starts from 2.
Yes, sir. Yes, sir.
0, 0, 0, 0, 0, 0, 0, 0, 0. Why all zeros?
Because of 0 runoff.
Yes. Next 2 are direct runoff ordinates. With runoff is how much?
1.
1 centimeter. From where we need to start then? See, total 6 hours ma. First storm 0 to 2. Next storm 2 to 4. Next part of the storm 4 to 6. So we need to start from 4.
Yes, sir.
So tell me the values now. 0. What is the next value?
2.
2. Good.
16.
8.
8, sorry.
8.
18.
This one I am talking about.
Yes, sir.
18.
32.
32.
45.
Okay.
80.
30 it is. Okay.
30.
19.
12.
12. 7. Like that so on. Okay.
Yes, sir.
Now I want to combine all the things.
Yes, sir.
Now what is the combination? Summation. Because DRH I want for 6 hours, not for only 2 hours.
Yes, sir.
At 0, it's 0. Next.
6, 7, 6.
4. Don't combine this. We will be combining only DRH.
Yes, sir.
Because from unit hydrograph we got DRH. We are not going to combine this one. 4,
Yes, sir.
16, 36, 64, 90 plus 2 is
92.
Plus next
68.
68 next 56 next 56 next
56. 61.
14 plus 50 45 plus 14 is 59, right?
Yes, sir.
59 next.
So 36.
Next 21, 12, like this going on.
Yes,
now what is the peak?
92.
Because we asked the peak flow only. Peak flow is 92, but Base flow is constant he given. Peak flow due to storm. Storm means nothing but flood hydrograph.
Yes, sir.
Due to storm means nothing but what?
Flood hydro.
Flood hydrograph. So what I told you in the previous slide, flood hydrograph means I want direct runoff hydrograph ordinate plus base flow.
Yes, sir.
The peak of direct runoff hydrograph ordinate is how much?
92.
Plus base flow is how much?
Base flow 5.
592 plus 5 is
97.
meter cube per second. That will be our answer.
Sir.
I will look at it for a couple of minutes. Please let me know if you have any doubts.
So second to our DRH ordinate will start from 2.
2.
Time t equals to 2.
Yes.
Yes, sir. And
because totally 6 hour storm.
yes, sir.
First we have divided 6 hours into 3 2-hour parts. Why? Because we know only 2-hour unit hydrograph.
Yes, sir.
So we are starting from this.
Yes, sir.
The same we can do using S curve also as in the previous case.
Yes, sir.
Any model can be done by S curve.
Yes, sir. We can. Yes, sir. Done, sir.
Okay. Just a minute. Okay. Next problem, please. Let's do this. A tracer takes 100 days to travel from well 1 to well 2, which are 100-meter apart. Okay.
Yes, sir.
The elevation of the water surface in well 2 is 3 meter below that in well 1.
Yes, sir.
Okay. Next, porosity equal to 15%, coefficient of permeability we require.
Yes, sir.
Now, what we'll be getting is, listen, there is well 1, we have the water, well 2, we have the water, Elevation of water level in well 2 is 3 meter below. How much is this elevation? 3 meter.
Yes, sir.
Now, how much is the time taken?
Sir.
100 days.
Yes, sir.
How much is the distance?
Sir, distance is 3 meter.
100 meter.
100 meter.
Distance is 100 meter.
Yes, sir.
Now tell me velocity, distance by time.
Yes, sir.
What is the velocity, ma? Seepage
1 meter.
velocity.
1 meter per day.
Vs is equal to distance by time, 1 meter per day.
Per day.
Now, what is the hydraulic gradient? Head loss per unit length.
Yes, sir.
Head loss is how much? 3 meter. Per unit length is how much?
Sir, 100 meter.
100 meter.
Yes, sir. 0.03.
0.00. Sorry, this is 100. 3 by 100. 3 by 100 is 0.03. We have it. Yes or no?
Yes, sir.
From Darcy's law, what I can write is V equal to Ki.
Yes, sir.
But we also know Vs is equal to seepage velocity equal to V by N.
Yes, sir.
So, from this, what is V? V, can I write it as Vs into N?
Yes, sir.
So, instead of V, I am substituting Vs into N, that is equal to Ki.
Yes, sir.
Vs is how much? 1 meter per day into N is how much? Porosity 0.15. That
Yes,
is
sir.
equal to K into I is how much?
0.03.
K equal to 1 into 0.15 upon 0.03. What is the answer?
Five. Five.
5. Five units is?
No. Yes, sir.
Units is meter per day.
Yes, sir.
Good. Let's solve the next problem. We'll do a bit recent gate questions. We are not going to do this things. Yeah. 2010, 2012 are enough old questions.
Yes, sir.
Tomorrow we will solve especially 22, 23, 24 questions.
Okay, sir.
As we done in the previous class.
Yes, sir.
Okay, let's do this. The intensity of irrigation for Kharif season is how much?
Sir, 50%.
50% with a cultivable command area of, this is off actually, 50,000 hectare. UT for the Kharif season is 100,000 hectare per cubic. Assuming transmission loss of 10%, required discharge at the head of canal is how much? Okay. First, what is cultivable command area? How much is it?
Sir,
50,000 hectare.
7 hectare.
Now, out of this, intensity of irrigation for Kharif season, how much is it?
50%, sir, 25,000.
Now it will become cultivable, not commandable, cultivable area. That is, out of cultivable area, how much area can you cultivate?
Yes, sir.
Can you grow the crop? How much is it?
Sir, 25,000.
It's 50 by 100 into 50,000. Yes or no?
Yes, sir.
25,000 hectare.
Yes, sir.
It's 25,000 hectare. Next, duty of kharif season, how much?
Sir, 1,000 hectare per cubic.
Hectare per cubic. I want the discharge, ma. Therefore, discharge equal to duty. I can write it as discharge upon area.
Yes, sir. Duty into area.
Sorry. Discharge equal to area by duty. Q equal to area upon duty. Okay. Therefore, duty equal to area upon discharge.
Yes, sir.
Now, what I want here is discharge itself.
Yes, sir.
Duty equal to area upon discharge. I want discharge. I
Yes,
want
sir.
discharge. How much it is then? Tell me.
25.
I want Q. Area is how much? 25,000 hectare.
4,000. Yes, sir.
If you forget the formula also, I will tell you a simple logic. Here you have hectare. Here you have hectare per cubic. So once when you will be getting the cubic is when you divide hectare with hectare per cubic.
Yes, sir.
So 25,000 hectare upon 1,000 hectare per cubic. Cubic means meter cube per second.
Yes, sir.
How much is it then? 25 cubics. Cubics means meter cube per second.
Yes, sir.
Now, listen.
Yes, sir.
This is head of the canal. This is the field. I want 25 meter cube per second here. During transmission, there is a loss of 10%. How much discharge you require at the canal head? Tell me. Are you understanding?
Yes, sir.
At the field, you require 25 meter cube per 1 second. But in this, meanwhile, there is a loss of 10%. So how much duty, how much discharge you require?
Thirteen point.
Why 13 point? What are you doing? I don't know. I don't understand. Please listen, ma. Listen. 10% loss means, for suppose, if you are transferring x meter cube from this point, there is a 10% loss. How much will reach here?
X minus 10%.
Of x?
Yes, sir.
X minus 10% means 10 by 100 of x. How much is
Yes.
it?
0.9x.
So similarly, if this is x, this is 0.9x.
Yes.
0.9x is equal to 25. What is x then? 25 by 0.9.
Yes, sir. Sir,
How much is it?
27.78.
Understood?
Yes, sir.
So one thing is very clear. We need to have a higher discharge at this point. Then only after making 10% loss, you will be getting 25 meter cube per second.
Yes, sir.
Understood?
Yes, sir.
Look at this. Please let me know if you have any doubts in this. Any doubts in this?
No, sir.
Yeah. We will do this. Duty means the number of hectares of a land irrigated by 1 cubic of discharge.
Yes, sir.
I'm telling you, if you have any doubt, what is duty? With 1 meter cube per second of discharge, how much area in hectare that can be irrigated?
Yes, sir.
Okay.
Yes, sir.
Therefore, duty equal to A by Q. That is with per unit discharge, how much area you can irrigate.
Yes, sir.
What is delta?
Depth of.
Depth of water required by the crop
Yes, sir.
to attain full maturity in its base period.
Yes, sir.
Delta is the depth of water required by the crop
Yes,
to
sir.
attain full maturity during its base period.
Yes, sir.
We have a relation delta and duty. Delta equal to 8.64 B by D,
Yes, sir.
where B is the base period in days. Delta is the depth in meter. Listen, units are very important. B is base period in days.
Yes, sir.
And
Day per meter.
B is the base period in days. D is the duty in hectare per cubic.
Sir.
What is D? Hectare per cubic. D is the duty in hectare per cubics. Now, using this, solve this problem. Take 5 minutes and solve this problem. I will show this first. Take a screenshot of this.
Just a minute.
Hmm.
Yes, sir. Done, sir.
Solve this problem using that concept. First find duty,
Yes, sir.
then from duty find area. We know delta equal to 8.64 B by D, where D is the duty. First find duty, after that find area. Because we know Q equal to A by D
Sir.
or D equal to A by Q.
Yes, sir.
Shall we do this?
Yes, sir.
The command area of a canal grows only one crop, that is wheat. Okay. Base period of wheat is how much?
120 days.
Base period B is given by 120 days. Total water requirement delta is how much? 40
Yes, sir.
centimeter. But I want delta in which unit, ma? Meter.
Yes, sir.
You see this? Delta should be in meter.
Yes, sir.
0.4 meter. Next. From this, you know, delta is equal to 8.64 B by D.
Yes, sir.
Delta is 0.4, that is equal to 8.64 into B is 120 upon D. Tell me how much is D? 8.64 into 120 upon 0.4. How much is D, ma?
Sir, 2592.
2592 units. Hectare per cubic.
Yes, sir. Hectare per cubic.
Listen. For 1 cubic, you have 2592 hectare. But the discharge is 2 cubics. Total how much area?
2 times.
2592 into 2.
Yes, sir. 259.
5184 hectare.
Yes, sir. 5184 hectare.
As simple as it is.
Sir.
Any doubt in this?
No, sir.
Shall we move forward?
Yes, sir.
Let's do this. Transplantation of rice required 10 days and total depth of water required during uh, delta equal to 8.64 B by D. Okay. Transplantation requires how many days?
10 days.
That is base period, I guess. Base period, yes. And total depth of water is how much? 48 centimeter. That is delta.
Yes, sir.
Delta equal to 48 centimeter.
Yes, sir.
Next, there is an effective rainfall of 8 centimeter. There is a rainfall also we have. Duty of irrigation in hectare per cubic is dash. Try to do this. Hmm.
T8 centimeter.
We have B is how much? 10 days.
Yes, sir.
During transplantation, there is a rainfall also.
Yes, sir.
Water required is 48 centimeter. Ma. Out of 48, you have 8 centimeter rainfall.
Yes, sir.
So how much you need to provide?
40.
48 minus 8 is 40 centimeter.
Yes, sir.
Therefore, delta from this water we ask duty D equal to 8.64 B by delta. Yes or no?
Yes, sir.
8.64 into B is how much? 10 days.
Yes, sir.
Delta is how much? 40 centimeter is how many meters?
10 power 3. 10 power minus 3.
1 meter is 100 centimeter. So 1 centimeter is 1 by 100th of a meter.
Yes,
So
sir.
40 by 100 is 0.4 meter. Clear? Not mm. What is the answer?
Sir, divided by.
Yes, please.
Sir, 216.
216. Units, please.
Sir, hectare per cubic.
Good. Practice these kind of questions also.
Yes, sir.
Tomorrow we will do, in the next class, that is tomorrow, we will do the questions on 2022, 23 and 24.